Okay, so as we look at example 5, I hope you are getting the idea that when we're asked a question, so we're given a rate, right? We're given, in this case, the rate of potato consumption. In the last problem, we were given the rate of acceleration. When we're given a rate and we want to know how much, we want to know the cumulative effect, that's what we're doing when we take the integral. So in this problem, we're given a function, which is the rate of potato consumption, which is that consumption is a function of time, and it's equal to 2.2 plus 1.1 to the t power millions of bushels per year. And the question says how many bushels were consumed from the beginning of 1972 to the end of 1973. However, the function starts out in 1970. So what we want to think about, t is years since the beginning of 1970. So this is going to end up being the integral from 2 to 4, because 1972 is 2 years since the beginning of 1970, and then the end of 1973 is 4 years since the beginning of 1970. So that's going to be the integral of 2.2 plus 1.1 to the t power. All right. So we are going to integrate this. In this particular example, they are just doing the integration with a calculator, so they're not doing without calculator integration here. There is an integration rule for things to the t power, but we won't talk about that here in this example. So remember that the emphasis in this section is just on figuring out how to use an integral to answer a question. So we're not so worried right now with the details of integration. The worksheet you have instead of a new weekly homework, which is a circuit on mixed integration, on that, you should do your best on most of the problems to try to integrate without a calculator. But on this particular section, using a calculator to help you once you figure out the integral is perfectly okay. All right, so in this problem, from noon until 6 p.m., the rate at which people enter an amusement park at time t is given by the function e of t, for which the graph is shown in figure 8.3. So that's the rate. So that graph represents the rate at which people enter the park. People are also leaving the park at a rate that is equal to an equation. So the question says if there are 3,000 people in the park at noon. So, remember back in the particle problem where the position at time 0 was 5? In this problem, the number of people in the park at time 0, which is noon, is 3,000. How many people are in the park at 6 p.m.? Rounded to the nearest multiple of 100, right? So think about what's happening here. We start out with 3,000 people in the park, and we have a rate at which people are entering the park. So the rate at which people are entering the park would be the integral from 0 to 6, because remember noon is 0, of e of t. Now notice that since we don't have a function for e of t, we're going to have to find the integral, the air quotes other way, which is to find the area under the curve. But we're also going to have to subtract the people who are leaving the park, which is the integral from 0 to 6 of 50 times 2 plus t squared e to the negative t over 5. Right? When I see this function right here, I am hoping that this is a calculator question, because finding the antiderivative of that would be super challenging, and I don't want to do it. So the piece that I have to do without my calculator is this guy right here, right? So I'm going to look at my graph up here, and I'm going to find this area right here, and I'm going to assume that you know how to find area. I'm not going to do that work for you. So I'm going to scroll down. The estimate of the number of people who enter the park, if you need help with the calculations, which I don't think you do there, they do it here, is 2,106. Oh, sorry, that is not right. That answer right there is 3,200. And then this integral, what you want to do in your calculator, is 2,106. So the 3,000 we started with, plus the 3,200, minus the 2,106, there's about 4,094 people in the park at 6 p.m.